Okay, so in this video, we're simply going to talk about redox reactions, and we'll begin by defining what redox implies. So reduction simply means the gaining of electrons. So we just say the gaining of electrons. So we are going to, gain of electrons. We're going to define reduction and oxidation in terms of electrons, but there are other ways that we can define reduction, like the gaining of hydrogen is also reduction. If you gain hydrogen, then the loss of oxygen is also called reduction. Yeah, so whenever we discuss oxidation, we have to be precise with what substance we are defining it with respect to. Yeah, so interesting enough, here we're going to talk about electrons. So oxidation is simply the loss of electrons. So when something loses electrons, it becomes oxidized. Then it's also the loss of hydrogen. Then it's also the gaining of oxygen. That's also another way that we can describe oxidation. Now, these reactions that we're going to be looking at specifically are going to have the movement or the transfer of electrons from one side to the other. But before we do that, there are certain rules that you must know with regards to the elements or the atoms about what we call oxidation numbers, meaning they are combining power or ability, so to say. Yeah, so the rules are very simple and straightforward. I'll just give them to us here. So the rules are here. We're just saying they're what we call oxidation numbers. Oxidation numbers are simply the charges that these atoms are going to assume whenever they are combining with other atoms. The main reason why atoms bond in the first place is for them to be stable, right? That's the reason why they combine. But then their ability to combine is influenced by their valence numbers or their valence charge. Now we're going to be calling that to be oxidation numbers. That's what we are simply saying. So for example, the rule is that pure elements, the oxidation number is what? Is 0. For monatomic ions, the charge on them is simply their oxidation number. For example, if I give you sodium, so sodium is a pure element. And if it's found in group 1, there's a rule to say group 1 elements, their charge is what? Is positive 1. And their valence as well, when this guy loses, it becomes sodium plus, meaning the charge is simply a positive 1. This is going to be the oxidation number for sodium. So we have for fluorine, these are fixed things. These are fixed oxidation values that are standard. So for fluorine, when it's bonding to something, its charge is a negative 1. And for hydrogen, whenever it's bonding to something, it has a charge of a positive 1, unless in peroxides where it has a negative 1. Peroxides are simply compounds where hydrogen will have the same number of atoms as the other guy it's bonding to. So for example, this guy is a peroxide because they're in a ratio of 2 to 2. Yeah, so that's the only time we have an exception. The same applies for oxygen. The oxidation charge of oxygen, whenever it's bonding to something, is a negative 2. But in peroxides as well, it will presume a negative 1. Yeah, then for neutral molecules, we take the charge to be 0. For diatomic molecules, we take the charges as well to be 0. For group 1, group 2, we're taking it to be the positive 1 and the positive 2. For carbon, it ranges. It can be anything between negative 4, negative 3, negative 2. It can have a negative 1, 0, positive 1 until you reach a positive 4. Yeah, because carbon has the ability to either lose or gain because it has half the number of electrons it needs in the outermost shell. Instead of having 8, it has 4, right? So it can either lose those 4 or gain those 4, or any number that can be found within these ranges that have been given here. Yeah, so these are basic rules. Now, in case you're wondering, what are these for? We're just here to balance redox reactions. Well, these are important because if I was to give us something that looks like this, if I was to give you to say, can you find, if I was to ask to say find the oxidation number of CR in, so let's say I give you CR, there is a 2 there, there's a 7, and I put a negative 2 there. So There was no chromium from the table. Cr is chromium, right? From the table, there is no chromium, but oxygen was present. So according to this, we're simply going to say the oxidation state for chromium is, we're going to call it X, and there are how many chromium atoms? There are 2 of them, so we'll multiply this by 2, then we'll say plus. There are 7 oxygens, so we'll say 7, and the oxidation state for oxygen, when it's combined with something, is what? Is a -2, right? Then this is going to be equated to the overall charge on the molecule. So if there was no charge, we would have equated everything to 0. But because there's a -2, we equate this to a -2. Then we solve for X. This is simply going to be that -2. Then this is going to be 2X is -2 plus a 14. Then this will give us 2X is equal to, this will give us a 12. Then you divide by 2. This will just give you X is equal to a 6, right? So the oxidation state for chromium is a +6. Which makes sense because this whole thing, you have 2 times 6 because each chromium has +6. So there are 2 of them. That's going to give us a +12 plus the 7 times -2 of oxygen. So 7 times -2. When you sum up these, that's where the -2 is coming from, the charge that you are seeing on top there. That's the overall charge of this chromite ion. So maybe I give us another example for something that is not on the table. For example, I asked for the oxidation state of nitrogen. Let's say nitrogen in, I'll say this, I'll give you this so that you see the difference. I'll also say in the ammonium ion. So let's say we have this is a positive there, right? So for the first one, nitrogen, we don't know, so we'll put X. There's only 1 here, right? There's a 1 there, so we'll multiply this by 1, so it's just going to be 1X, then plus. Hydrogens, there's a 3. Hydrogen takes what? Takes a +1, right? This is going to be equal to 0, is it? If we go to here, hydrogen as what? Takes a +1 as its combining power. There is no charge on top, that's where the 0 is coming from. This is going to be X plus a 3 is equal to 0, meaning X will be -3. So the combining power of nitrogen here is a positive what? I mean a -3. Then how about in this guy? We'll just say X plus 4 by 1. This is equal to a +1. This will be X plus 4 is equal to 1. This will be X is equal to 1 minus 4. Still the same. It's what? -3. So we're saying the combining power of nitrogen is what? Is -3 in both cases. So this is the importance of knowing these rules or mastering this table here. Yeah, we need this table for our incoming calculations. Yeah, so now we're interested in discussing reduction and oxidation. Now there's an example that we're going to focus on. Now, like I said, oxidation is simply we say oil rig, right? We use this oil rig. So we say oxidation is the loss of electrons and reduction is the gaining of electrons. So whenever a chemical reaction is happening, whenever there is loss, meaning there is gain, right? These guys happen at the same time simultaneously. So we're saying they happen together at the same time. And we have to learn to balance the equations that are given in ionic form. And this is what we mean by balancing a redox reaction or equation. Now, this can either be done in an acidic media or in a basic media. And the method I'm going to show you here can work for anything. And this is going to, this is called the ion electron method. The ion electron method is the method we're going to use right here to balance this in acidic media. Then we'll proceed and then balance it again in a basic media. So, of course, the definition of an acid has not changed. An acid is simply something that produces hydrogen ions as the only positively charged ions in what? In aqueous or in a solution, right? So, when given an equation like this and told to balance it in an acidic solution, you have to split it first. So, I'll split it in such a way that anything that is common on the left will be twinned into something that is common on the right. So I'll get this. So there is chromium, and this guy here has chromium. Then this has carbon, hydrogen, and oxygen. I'll also connect this to these two guys here. So we'll split it. So when we split it, I'm going to say Cr2O7 2 minus is directly related to Cr3 plus. Again, the other guy down, I can just write it here. I'll say CH3, CH2, all that. This is the same as carbon dioxide plus water, right? This is what you have. Now, you have to identify which in between the two equations, the two half redox equations, is going to be the oxidation one and the reduction one. So you just look at the charges or what has transpired. So if you look at the overall charge here, the overall charge here is what? The overall charge here is -2. The overall charge here is a +1, +3. So what happened? For it to move from being negative to become positive, meaning it lost, right? So if it lost electrons, meaning we have what? We said what? Oxidation, right? This is the oxidation half reaction. Then this is the reduction half reaction. It's automatic. So we identify them. So we have the oxidation half reaction and the reduction one. So you always have to split it like this. Then we'll start balancing them. Yeah, so step number 1, we're going to balance oxygen. Later on, oxygen and hydrogen are going to be balanced later on. So step 1, I'll just write it here. So step 1, we say balance all other atoms except oxygen and hydrogen. That's what we're interested in. That's what we're going to do in both cases. So chromium here, there's what? There are 2 of them here. There's only 1, right? So I'll put a 2 there. Then carbon, there are 2 here. There's 1 there. So I'll put a 2 there on carbon. So hope you've seen what we've done. According to step 1, right? Balance everything else, but not hydrogen or oxygen. So we look at chromium is the only new thing there. If we ignore oxygen, there's only chromium. There are 2 here. There's 1. So no wonder we have put a 2 this side. We have 2 carbons on the reactant side. We had 1. So no wonder we're putting a 2 to balance the carbon atoms. Step 1 has been accomplished. Then we go to step 2. Step 2 says balance oxygen using water. That's what we want to do. So you balance oxygen using water. So if you come on both equations, look at the equations that you've been given. So here there are 7 oxygen atoms on the reactant side, right? Here there is no oxygen. So meaning I'll put water on the right because it's a side that is deficient of oxygen. It is lacking 7 oxygens. We can't just put 1 water molecule because 1 water molecule only carries 1 oxygen atom. We need 7 of them. That's the reason why we're adding 7 water molecules on the right, so that the oxygen atoms are now balanced in both on both sides. So this is the first oxidation half reaction. We've balanced it. So let me put a demarcation here. Yeah, then this side, look at the oxygens here. You just have 1. Here you have 4. 5, right? You have 5 here, you had 1, so meaning we have to put 4 water molecules this side as well to balance. So we're putting it this side because there is 1, so we have to have 5. This side is what? Is 5. So that's what we are having. So we have followed up step number 2. The next step is to balance hydrogen using H+ ions. So step number 3, we just say balance hydrogen using the hydrogen ions, positively charged, right? So you look at the side that is deficient of hydrogen, hydrogen atoms. Yeah, so which part is lacking hydrogens? So this side, there are no hydrogens. Here we have 14 of them, so I'll add a plus, 14 H+. Because you had 7 times 2, that's 14, right? So that's the 14 we're adding this side. Here you have 3, 4, 5, 6. That's 6. 6 plus 8. This will give us what? 6 plus 8. That's going to give us a 14, right? Because we are having what? We are having 3, 4, 5, 6 plus 8. Here there are 8. So that's a 14. Then this side you have how many? You just have 2. So meaning here we can add 12 H+ ions. So now to make life a bit interesting, I'll just write them nicely here and neatly. So the reduction half equations, if I was to write it, let me just copy it. Okay, so these are our equations here. I've just rewritten them down, and I've indicated the new added parts in yellow. So hope you're able to see the difference. And we're just from completing step number 3, where we are balancing the hydrogen atoms using the hydrogen ions. That's where the 14H plus is coming from, because you have 14 hydrogens this side. Then that's where the 12H plus is coming from, because you had 14 this side and we only had 2 this side. So to balance things up. Then from here now we have to balance electrons. That's step number 4. We balance the charges, using electrons. So the charges here, let me just use a different color. The charge here is positive 14, right? The charge here is just a negative 2. The charge here is 2 times 3. That's a positive 6. The charge here is just 0. So you notice that 14 minus 2, that's going to give us 12. And 6 plus 0, that's going to give us 6. So now the difference between the charges. So the charge on the reactant side is 12. The charge on the product side is 6. So you find the difference and put it as the number of electrons on the side that has a bigger charge. So because electrons are negative, so if we add 6 electrons, so we are halving this. So 12 minus 6 will balance to give us 6 as well, right? So I'll repeat that again. You look at the charges on both sides, on every molecule or every ion. So here you have 14 positive 1. So 14 times positive 1 is positive 14. That's what you have. Then 1 multiplying negative 2, that's a negative 2. Then you have 2 times positive 3, that's a positive 6. You have a 7 times 0 because there's no charge there, right? This is a pure compound. So here you sum up this, you get a 12. You sum up this, you get a 6. Now we're saying the difference in the charges is 6. So we'll do the bigger number minus the smaller one. So that's the 6 difference that we are getting. That's the 6 electrons that we are going to add on the part that was having a bigger charge. That's what you have. The same thing will be done for the guy at the bottom. We'll do the same, the exact same thing. Here we have a 0 charge. Here we have a 0 charge. Here we have a 0 charge. We have a 0 charge. Here we just have a positive 12, right? So this is 0 and positive 12. That's what you have. Now, if you have a 0 and a positive 12, the difference between the two is simply positive 12, right? And we're going to put it as the number of electrons this side as 12 electrons on the part that has a bigger charge. Now, they are balanced. It's 0, 0. The charge this side is 0. Even the charge this side is 0 because positive 12 plus negative 12 will give us a 0. So now that we are here, we can now try to balance the electrons. You are seeing this is happy, but we'll try to balance the electrons like the same way you balance in simultaneous equations. So this is 12, this is 6. So I'll multiply this by 1, then I'll multiply this equation by 2 so that we balance them. So let me write my answers. I'll write our answers in green. Yeah, so in green, or rather I can just change this to just be 12 electrons plus this is 28 hydrogens. So the number affects everything. This is 2, Cr2, oxygen 7, there's a negative. This is a 4, Cr3 plus, and this is going to be a 14. That's what you have. Then the bottom part does not change. It still remains the same. It's still going to be, because the 1 doesn't affect anything. The change by 1 is still the same thing. So this is what we're going to get. Yeah, so carbon, then you have water, then you have 12 electrons and 12 hydrogen plus, right? This is what you are getting. So now I've just rebalanced the equation. So now we are going with this. This is what we have and this is what we have. The idea is that the electrons, the number of electrons has to be the same so that we cancel them. So I can erase this equation here. Let me just erase this guy so that you are not confused. The idea here is that we need to balance the electrons, and they are balanced here. And reason being, we don't need to see electrons in the last equation. That's the reason we are having them cancelled. So this is 12 and that's a 12 because they're on opposite sides, right? So things on opposite sides can cancel. Things on the same side can add up. So again, you can have, you have what? You have four water molecules here. They will cancel with this to leave us with 10 water molecules. You can have that. That can happen. You have 28 hydrogen this side. So 28 minus 12, that was simply going to give us what? A 6. Then that's a 1, right? So 16H plus, that's what you have. Then what else can cancel? Nothing can cancel. These two waters are on the same side, this water and this water. So the balanced equation here will just be, if we combine the two equations, we're going to get 16 hydrogen ions plus the 2 CrO7, 2 negative. So we're done here. Then we get this guy as well, plus CH3, CH2O, then plus, or I mean gives us, we have this now. This, so I've gotten this, what remained here, that's that, and also this guy, this is that, and also this guy here, this is what you're seeing there. Then the product side, we have this, that's 4 Cr3 plus. Then we have this guy here, which is 2 carbon dioxides. 10 water molecules plus 1 water molecule give us what? 11 water molecules, right? So this right here in white is our balanced final equation, and we have balanced it in acidic because in acidic, H plus must be able to appear by the time we are done. So this equation here is balanced in acidic solution or acidic media. So this is balanced. Now, if they asked us to balance it in a basic media, would have continued from here and add an equivalent number of OH minus with respect to the hydrogen ions that you have. So you have produced 16 hydrogen ions, right? That's what you've produced in this acidic media. So we're going to add an equivalent number to this. So this has 16. So we're going to add 16 OH minus on both sides. That's how we balance in basic. If we want to balance in a basic media, we carry all the steps in acidic. Then when we reach at this point, when it's balanced now, we add an equivalent number of hydrogen ions to the hydroxide ions. So we are going to add this on both sides. So let me just write it here for the sake of the video. So I'm going to add 16 OH minus here and also 16 OH minus this side. Reason being, this is going to cancel with that to give us 16 water molecule. That's what's going to happen. This and this will go to give us 16 water molecules this side. Then this is fixed. Then you can just bring it down here and say you have 16. Before we even talk about the 16 water molecule, there are 16 water molecules here, right? Then here there are 11. So they can actually be subtracted because it's like this coming on the other side. So yeah, we can just have 16 minus that. That's going to be 16 there. It will give us 5, right? 5 water molecules. Then the 11 water molecules disappear. So we'll get 5 water molecules. Then plus 2 Cr2, 7, 2 negative, plus CH3. Then CH2. Then this is giving us, this is going to give us the 4 chromium 3 plus. Then you have 2 carbon dioxide molecules. Then you have 16 hydroxide ions. So this now has been balanced in a what? In a basic media. Then you get done, you leave it there. If they wanted it in basic media, would have concluded and left it here. But if they wanted it in acidic media, would have left it off here when we had this thing here that we got. This is in acidic media. So this is technically how you balance a redox reaction, whether acidic or basic, using the ion electron method, which is always recommended because it doesn't show electrons in the outermost, in the final equation that you get, and it eliminates anything that's common, that's repeating, and sums up anything that's repeating itself on the same side. So having said that, I'll just leave you with a quick question. So a simple task. Try to see if you can follow what we've done in the video. So I will give you a hint on how you can go about this. So you have the same chromium. So I'll give us this. There's Cr2. There's O. There's a 7 there. There's a 2 negative. This is producing ion 3 plus. That's a 3 plus. That's a 3 plus there. And you have Cr3 plus. So you're going to group them like this. You take this to be your first half reaction, and you take this to be your second half reaction. So try this. By the time you are done, feel free to consult. If you have any questions, just inbox me on WhatsApp. And if you're also interested in having personal tuitions or just need group lessons, feel free to contact me. We're running a promotion at the moment, so it would be wise if you join at the moment before the stress accumulates. Thank you so much for watching. Don't forget to subscribe.